What if everything you knew about Jupiter was wrong? For decades, we thought we understood the auroras of Jupiter. But then, on a cold Christmas night, NASA's most powerful telescope caught something impossible. A flash, a burst, and then it vanished. This isn't science fiction, it's science. From 484 million miles away. These new images from the James Webb Space Telescope have left even scientists speechless. Let me show you what they saw. Setting the scene, let's take a step back. Before we talk about what James Webb saw, we need to understand the incredible world we're looking at. To most of us, Jupiter is just that big striped planet with a red spot. It shows up in science books, screensavers, and telescope apps. But behind that familiar image is something truly alien, something we're only beginning to understand. Let's start with the basics. Jupiter is a gas giant, the fifth planet from the Sun, and by far the largest in our solar system. How big? You could fit every other planet inside. It didn't still have room to spare. Its diameter is over 88,000 miles, more than 11 times that of Earth. It's so massive, it holds over 2.5 times the mass of all the other planets combined. But it's not just the size. Jupiter spins faster than any other planet. One day there lasts just under 10 hours. That rapid rotation gives the planet its bands, those stripes we see in every image. But it also drives violent winds, some reaching over 400 miles per hour. And then there's the Great Red Spot, a swirling, blood-colored hurricane that's twice the width of Earth. It's been churning for at least 350 years, possibly longer. That means it's older than most nations on Earth, older than the invention of electricity, older than the steam engine. Jupiter is loud, angry, and wild, but one of its most stunning features is silent, the auroras. Now, we've all seen pictures of auroras here on Earth. Northern lights, southern lights, shimmering curtains of green and purple, dancing gently in the night sky. They're beautiful, peaceful, created when the solar wind meets our magnetic field and sends particles down into our upper atmosphere. But on Jupiter, auroras are something entirely different. They don't shimmer, they roar. They aren't soft waves, they're blazing rings of fire. And they don't come and go with the solar wind. They're always there, always burning. Hundreds of times more powerful than anything we see on Earth. Some of Jupiter's auroras are so massive, they would cover our entire planet several times over. They're visible in X-rays. They pulse in ultraviolet. They bend and twist under forces we still don't fully understand. Here's what makes them even more mysterious. They're not powered just by the Sun. They're powered by Jupiter itself, and by one of its moons, Io, a small volcanic moon, locked in a constant gravitational tug-of-war with Jupiter and its neighboring moons. It's the most volcanically active object in the solar system. It erupts constantly, spewing plumes of sulfur and gas hundreds of miles high. All that volcanic material escapes into space, forming a massive ring of charged particles around Jupiter. This ring becomes a kind of fuel. Jupiter's magnetic field grabs it, accelerates it, and flings it toward the poles. When those particles crash into the planet's upper atmosphere, they ignite. That's what we see as Jupiter's auroras. And this is no ordinary magnetic field. Jupiter S is the most powerful of any planet in our solar system, about 20,000 times stronger than Earth S. It stretches millions of miles into space, so large that if you could see it with the naked eye, it would appear bigger than the full moon in our sky even from Earth. Scientists have been watching these auroras for decades. We've used the Hubble Space Telescope. We've sent spacecraft like Galileo and Juno into orbit around the planet. With those tools, we've mapped out the auroral patterns. We've seen pulsing rings. We've watched glowing footprints where Jupiter's moons interact with the magnetic field. We've even detected X-ray emissions, something no one expected. But even with all of that, something still didn't make sense. There were moments when the auroras behaved strangely. Flashes that appeared and disappeared in seconds. Bright bursts that didn't line up with solar activity. Patterns that broke the rules. Scientists tried to model it. They ran simulations, but none of it matched. That's when they turned to the James Webb Space Telescope, the most advanced observatory we've ever sent into space. Webb has an advantage. It can see the universe in infrared and ultraviolet. That means it can look through gas and clouds and reveal heat and light that are invisible to human eyes. When it pointed its mirrors toward Jupiter, especially its polar regions, where the auroras rage, it saw something that left even seasoned scientists speechless. A flash, a burst of light so brief, so fast it looked like the aurora was popping like a firecracker. And then another, and another. They called it the pop and fizz effect. These weren't steady glowing arcs, they were eruptions, unstable, electric, and completely unexpected. Nothing in existing models explained this, and yet, there it was, captured in real data by the most powerful telescope in human history. So what's going on? Why is Jupiter's aurora acting like it has a pulse, like it's alive? No one knows yet. Some scientists think it's due to interactions deep within the planet's magnetic field. Others suggest it's linked to Io's volcanic output, spiking in unpredictable ways. Some believe it might be a completely new kind of atmospheric behavior we've never seen before. Whatever it is, it's real, it's wild, and it's beautiful. The discovery pop and fizz phenomena. So, what exactly did the James Webb Space Telescope see in December 2023 as the world was celebrating Christmas? JWST was silently watching Jupiter from nearly 1 million miles away. Its instruments focused on the planet's poles where the auroras glow bright. Scientists expected to see the usual patterns, stable light rings, maybe a few pulses. Nothing too surprising. After all, we've been watching Jupiter's auroras for years, but this time, the light didn't behave the way they expected. It flickered, not gently there were sudden flashes, bursts of energy that appeared and vanished in less than a second, and they weren't just random blips. They came in rapid, rhythmic, pulses like sparks from a live wire. It wasn't just a glow, it was more like a fireworks show, one that no one had planned for. This strange behavior was quickly given a name, pop and fizz, because that's exactly what it looked like. Pop, an intense flash of ultraviolet light, fizz, tiny bursts that scatter and fade. To the naked eye, it might look like static, but to scientists, it was a sign of something deeper, something we hadn't seen before. So what could cause this? Let's break it down. First, we need to understand how these auroras are generated. Jupiter's magnetic field grabs charged particles mostly from its moon eye and channels them into the upper atmosphere. There, they collide with molecules of hydrogen, releasing energy in the form of light. This process is usually steady, consistent. You get bright bands and glowing ovals, but not bursts. Not like this. One theory suggests that the bursts are a kind of space weather, extreme storms in the magnetic field, similar to solar flares. Another theory points to turbulence in the plasma ring around Jupiter. Io is constantly feeding that ring with volcanic material, and if the output suddenly increases, it might trigger surges of energy in the aurora. Think of it like this. If Earth's aurora is a slow-burning candle, then Jupiter's is a lightning storm, and James Webb just caught a bolt in mid-strike. But there's more. The flashes were incredibly short-lived, less than 2 seconds long. No telescope had ever recorded that kind of detail in Jupiter's auroras before, because no telescope had the sensitivity and speed of JW. This is where the real excitement began. Some scientists even questioned if the instruments were malfunctioning. That's how unusual it was. They double-checked everything. Calibration, background, radiation, even cosmic interference. But no, the data was clean. The flashes were real. In some frames, you could see the entire auroral oval light up, like it had been hit by a pulse of electricity. Then, just as quickly, it faded. That's when scientists realized they were seeing something totally new. A type of magnetic or atmospheric interaction we don't fully understand yet. And that is thrilling, because it means Jupiter is more dynamic than we thought, more alive. This planet, which we've stared at for centuries through telescopes, still has secrets, still has behaviors that don't fit our rules. The pop and fizz phenomenon wasn't a glitch. It wasn't noise. It was Jupiter speaking in a language we've only just begun to hear. And remember, this is just the beginning. JWST has only started its work. It wasn't even built specifically to study planets in our own solar system. And yet, it's already rewriting what we know. The discovery has sparked new conversations among scientists. Are there layers in Jupiter's upper atmosphere we've never mapped? Is there a new kind of particle interaction happening up there? Could this help us understand exoplanets, gas giants orbiting other stars? The questions are multiplying, and so are the possibilities. For now, all we know is this. On a cold December night, our most advanced space telescope caught a giant planet blinking, and in that blink, we saw something beautiful, something violent, and something totally unexpected. Why? It matters, beyond just a pretty light show. So, what does all of this really mean? Why should we care about some lights flickering on a planet that is over 400 million miles away? It's a fair question. After all, this isn't a new it's not alien life. It's not even a new moon. Just light, coming from a planet we've already seen thousands of times. But here's the thing. This discovery isn't just about pretty lights. It's about unlocking a deeper truth. Jupiter's auroras are telling us a story about energy, gravity, chaos, and balance. They're proof that the universe is not silent. It's moving. It's changing. It's full of patterns we don't yet understand. When the James Webb Space Telescope captured that burst of ultraviolet energy, it cracked open a new door in planetary science. We're now realizing that Jupiter's atmosphere is far more dynamic than we thought. Its magnetic field behaves in ways we've never modeled. Its interaction with its moons, especially Io, is more violent, more complex, and more alive than expected. These aren't just facts for textbooks. They're pieces of a larger puzzle. Because when we understand how gas giants like Jupiter work, we start to understand how planets form, how solar systems evolve, and even what kind of conditions might make other planets habitable. That's right, Jupiter might help us find Earth 2.0. How? Let me explain. Most of the planets we discover outside our solar system called exoplanets are gas giants. They're easier to spot because they're massive, and they block out more light from their host stars. But we know very little about how those distant giants behave. We can't see their atmospheres clearly. We don't even know how their magnetic fields interact with nearby moons, or if they even have any. Jupiter is like a lab for testing those ideas. It's close enough to study in detail, and yet wild enough to still surprise us. That Papanfis effect we saw, it might exist on exoplanets too, and if it does, it might help us detect things like volcanic activity, magnetospheres, or even hidden moons orbiting those distant worlds. And here's something even more profound. Jupiter protects us. Yes, really. Its massive gravity acts like a cosmic shield. It pulls in comets and asteroids that might otherwise crash into Earth. Some scientists believe we wouldn't even be here if Jupiter didn't exist. Without it, life on Earth might never have had a chance to evolve. So when we study Jupiter, we're not just studying a gas ball with storms, we're studying our guardian. And now, we're seeing that our guardian is more complex and powerful than we ever imagined. Think about it for a moment. Even after centuries of looking up, we still don't fully understand the giant glowing planet in our own neighborhood. What does that say about the rest of the universe? If Jupiter still holds mysteries, what are we missing around Saturn, Neptune, planets in other galaxies? The discovery of this strange aurora isn't the end of a story. It's the beginning. Scientists are now developing new models to simulate Jupiter's magnetosphere. They're planning follow-up observations using both JWST and Hubble. And most importantly, they're starting to ask new questions. The kind of questions that could lead us to new theories, new discoveries, new ways of thinking about how our universe actually works. In a time when we're overwhelmed with noise, scrolling through screens, lost in algorithms, the universe still finds a way to remind us of something simple and beautiful. We don't know everything, and that's what makes science magical. Because every mystery brings a sense of wonder. Every unanswered question pulls us deeper into the unknown. And for just a moment, as we look at that swirling light above Jupiter's pole, we remember what it feels like to be small and curious and full of imagination again. The bigger picture. Let's take a step back. We started this journey with a single question. Why does Jupiter look like Then, we followed the trail from strange images captured by James Webb. 2 lightning storms swirling above the poles, two energetic outbursts seen through ultraviolet eyes. We talked about magnetic fields, volcanic moons, and invisible forces dancing across millions of miles of space. But now we're here, at the end of the story, and it's time to ask the real question. What does all of this mean for us? Because sure, Jupiter is beautiful, its storms are wild, its auroras are mesmerizing. But beyond the spectacle, there's something more. We live on a fragile blue planet, orbiting a medium-sized star, in a spiral arm of a galaxy we barely understand. And yet, with just a few decades of technology, we've built tools powerful enough to see deep into space, to peel back the layers of gas and radiation surrounding a planet like Jupiter. Think about that. For most of human history, Jupiter was just a bright dot in the sky, a mysterious light among thousands. Now, we can see its storms in motion, its auroras glowing in real time, its magnetosphere stretching farther than the sun itself. We're not just observers anymore, we're explorers, we're interpreters of cosmic language, and that's what science is, at its core. Not just data or numbers, but storytelling, the story of how the universe works, and how we fit into it. Jupiter reminds us of two things: how small we are, and how far we've come. That strange glow around its poles, it's a reminder that there's still mystery, still beauty, still wonder left in the world. We need that, now more than ever, because in an age of instant information and endless distraction, we forget to look up, we forget to ask questions, we forget that not knowing something is where all the magic begins. When you see Jupiter light up like that, you're not just looking at a planet, you're looking at energy, at gravity, at chemistry and motion and math, all colliding in ways we still don't fully understand. You're looking at nature's raw power on display, unfiltered, unedited, and entirely real. And the fact that we can witness it from Earth, that we can point a telescope across the void and catch a glimpse of this moment, is extraordinary. So the next time you see an image of Jupiter, don't scroll past it. Don't assume it's fake. Don't say, "Oh, that must be CGI." Stop, look closer, and remember, this is real. This exists. Right now, as you're listening to this, those auroras are still dancing. That planet is still turning, and space is still speaking. It's just waiting for someone to listen. If you felt even a flicker of awe from Jupiter's auroras, go ahead and like this video, subscribe for more cosmic stories, and tell us in the comments, which planet do you want JWST to reveal next?